The first has been introduced by President Biden. Images to be presented to the public from underneath the James Webb Space Telescope. Mysteries that transcend vast oceans of imagination, relics of a bygone era, strange traces of once thriving life waiting to be found. But in the middle, there is a glimmer of the allure of discovery, trepidation. What if these secrets were never meant to be found? Join us as we dive into 15 underwater depths, discoveries that have affected everyone, from the most brave explorer to those shaking. So, get ready to be fascinated and terrified at the same time. The James Webb Space Telescope, launched in 2021, was an amazing event. It soared to the top of the sky with a powerful European Ariane 5 rocket in the midst of South America's lush forests, adding a touch of the splendor of nature to the occasion. Thousands of scientists poured their wealth of expertise and effort from all over the world into this undertaking for 30 years, culminating in this significant achievement. However, such grand endeavors come with a lot of danger, and the possibility of failing was very real. Amazingly, everything came together with close to perfect accuracy. The telescope began a journey that lasted nearly 1 million miles, traveling for 30 days to its ultimate destination through space. The mysterious Lagrange point 2 was the destination, a location in space where gravity keeps a fragile equilibrium relative to Earth's position in relation to the Sun's orbit. This location was already home to additional space telescopes, such as the Planck and the Hubble Space Telescope, which makes it an ideal perspective for the James Webb Telescope. As the James Webb Space Telescope began its journey, NASA unveiled its ambitious primary program outline. First and foremost, in exploration-oriented realms. The objective of the telescope was to see the initial burst of light in the universe, a significant event in cosmic history. It endeavored to investigate the ancient celestial bodies prior to revealing the mysterious assembly of galaxies in the early universe, a stage of cosmic archaeology. Beyond this, the JWST was about to reveal great celestial spectacle's significance. It desired to look inside the guiding light from the stellar cradles of birth, the stars' beginnings, and the emergence of early planetary systems. Additionally, its pursuit extended to the panorama of planets, investigating the grand history of the planet's existence, including the mysterious beginnings of life. These scientific frontiers themselves had long eluded extensive investigation because of the inherent difficulties of examining the universe. Prior to beginning its observations of the night sky, the JWST went through a careful series of calibration and scientific tests. Procedures that included the use of a remarkable shield designed to protect its delicate equipment from the unstoppable assault of the sun's radiating heat and blinding light. This safeguard was essential in the cosmic void. A sizable structure made up of just 5 layered membranes, meticulously folded like a complicated accordion. The process of unfolding required a precise sequence of actions that ensured proper tension and alignment of every layer. The stakes were huge, as any misalignment might hurt this cosmic guardian, putting the ability of the telescope to observe the mysterious realms of the faraway universe at risk. It glided effortlessly through the initial tests that established the course for the next difficulty. The next task was to raise the telescope to a higher level, a delicate procedure despite the fact that it was already precisely where it needed to be. Careful preparation to carry out its fundamental duties laid out an intricate mirror as its primary component. The 18 hexagonal pieces that make up the mosaic required flawless synchronization to create sharp portraits of the heavens. The rehearsal for this was a ballet of fragility and complexity. Not just the massive sunshields unfolding, but also the elegant extension of its structure of support and the steady revealing of its primary mirror. The revelation in the mirror was merely the beginning of the artistry. Every aspect required perfect alignment to enable the telescope to complete its scientific quest. Yet, another complex calibration test involved the scientific aspects of awakening instruments one at a time, as if awakening these instruments' dormant sensors. These included the camera with a near-infrared range, mid-infrared and near-infrared spectrometers, and an instrument in the infrared range, each with unique abilities for observing the universe, adding new levels of mystery. Equally crucial, too. The mission was the alignment of the telescope's cosmic bearings, a process called commissioning. This involved engaging the telescope for calibration, using research markers and fine-tuning its goal to ensure that the instruments it used were fixed to celestial targets with precision. Precision was the basis for each of these tests, guarding the entrance, making sure the Webb telescope was set up and ready to embark on its odyssey to learn more mysteries of our universe. Such complexities of procedures brought about a sense of anticipation. Everyone in the scientific community held their breath, hoping for success, fully understanding that things in science often do not go according to plan. To everyone's amazement, the JWST passed each test flawlessly, success that is nothing short of remarkable. This monumental project brought together more than 300 institutions, organizations, and businesses from 14 states and 29 nations. July 2022, after enduring and overcoming each obstacle, the James Webb Space Telescope got the green light from NASA to begin its remarkable scientific voyage. It was proudly revealed that each of the 17 observatory modes of scientific instruments had undergone thorough examination and was now deemed ready for action. The telescope's primary function is to gather and concentrate light, revealing the distant celestial wonders. But what makes the JWST unique is the particular portion of the electromagnetic spectrum it observes. Whereas we humans can only see visible light, the JWST sees beyond into a secluded realm of cosmic phenomena, opening a profound shift in perspective. In our search for comprehending the universe, similar to a cosmic fire, the James Webb Space Telescope, a seeker that resembles a futuristic night vision camera, can look into the vastness of the universe's depths. Because of its enormous size, it can gather more light than any other telescope, allowing it to look at even smaller, further away wonders of the universe. But the best part is that it is freestanding in space, away from those annoying obstacles, in the atmosphere that frequently obscure our view, which is why they call it the watchful eye of the universe. But how exactly does this marvel work in practice? At its core, it has a massive 21-ton mirror. This enormous mirror catches and returns light to the telescope's intricate instruments. The JWST consists of a quartet of instruments, each with its own distinct cosmic talent. The first, the near-infrared camera, is its primary high-tech lens, taking stunning pictures of nebulae, distant galaxies, and other celestial marvels. The next in line, a near-infrared spectrograph, acts as a cosmic prism that separates light into its rainbow colors, revealing information about the objects it observes. The mid-infrared instrument, designed specifically to acquire infrared light, delves into the enigmatic beginnings of the universe, examine exoplanets, and even undertake a more in-depth look at our own solar system. The fine guidance sensor is the final component, a slitless imager and near-infrared spectrograph. These extremely precise instruments make sure the first point is in the right place, direction, and is especially sensitive to proximity. This combination of infrared light leaves no cosmic stone unturned. The actual has left no cosmic stone unturned. Having an understanding of the universe expanding, as the universe stretches and expands, the light from far away causes redshifts in space's corners. This means that the wavelengths of the light get stretched out, giving it a redder appearance than in its initial state. By observing the universe in this redshifted light, we can literally travel back in time and observe the universe as it existed in its infancy. Imagine being there when stars are born and learning about galaxies and the conditions of our universe in ancient times. The James Webb Space Telescope has a remarkable capacity to examine the universe's details, a feat that allows it to truly peer back in time. The further an object is from us, the longer it takes for its light to reach our telescopes. When a faraway object is the focus of the JWST's lenses, such as a galaxy, it's more than just capturing a snapshot of the present. Rather, it's like opening a cosmic time machine, showing how the galaxy appeared billions of years ago when its light first set out on its unique interstellar voyage. This capability enables researchers to delve into the universe's ancient history, a time when the first galaxies and stars were forming, providing an invaluable chance to investigate the processes that shaped our universe. Take note of the JWST's capabilities now. It made an impressive entry into the public eye on July 12, 2022. Following the unveiling of NASA's first batch of scientific illustrations in a live event. Despite the fact that these images were quite graphic. Imagine gazing at the incredible cosmic cliffs of the Carina Nebula or admiring the ethereal splendor of the Southern Ring Nebula. These images are more than just pretty pictures. They were openings that let in the vastness of space and time. But that's not all. The telescope went beyond diving into aesthetics and into the specifics of science. It examined the contents of the atmosphere of the fiery gas giant exoplanet WASP 96b, which provides important insights into alien worlds. Additionally, it presented us with an enthralling look at Stephan's Quintet, a group of galaxies ensnared in a mesmerizing dance of the heavens as they mix and merge. These images did not simply generate excitement due to their visual splendor. Though they unquestionably sparked enthusiasm, the revelations went as far as February 2022. When NASA first provided the world with a glimpse of the JWST's capabilities. The most shocking moment came when NASA announced the first glimpse on the web of starlight, a mosaic image of the 18 luminous dots that were dispersed, featuring the well-known star HD 84406. NASA's associate, Thomas Zurbuchen, in charge of the Science Mission Directorate, tweeted with excitement that as these 18 honed the web's focus, beacons from space would seamlessly blend together into a single bright star. This accomplishment signified an exciting milestone. It's illustrating the enormous potential of the telescope for future discoveries and explorations of interstellar space. In the weeks that followed, the JWST's odyssey progressed. On February 18th, NASA released an improved image of HD 84406. Where the 18 star copies were meticulously arranged into a captivating hexagonal structure. This gave us an intriguing look at the splendor that was to come once the observatory precisely positioned specific sections of its primary mirror, heralding the era of image stacking, which promised to open even more cosmic wonders. The nature of this exoplanet stands out from the rest. Among celestial peers, the James Webb Space Telescope is a giant among giants. Astronomers and scientists eagerly awaited the next set of discoveries from the telescope. The JWST's advanced instruments were not only made to take pictures, but also to study the spectral traces left by distant objects. This ability enables the telescope to determine the material composition of cosmic phenomena, shedding light on the components that make up far-off galaxies, stars, and planets. One of the most anticipated aspects of the JWST is its ability to see through cosmic dust, a capability essential for analyzing regions where stars and planetary systems originate. In infrared light, which the JWST is specifically tuned to detect more effectively than visible light. The telescope can observe the beginning stages of star formation and the complexities of the processes involved in the creation of planetary systems advancements that were previously hidden. Additionally, the capacity to investigate the atmospheres of exoplanets is a significant advancement in exoplanet study. By examining the light that traverses an exoplanet's atmosphere as it moves in front of its host star, scientists can identify chemical fingerprints of various substances and compounds. This method, known as transit spectroscopy, allows researchers to ascertain the composition of exoplanet atmospheres, including potential chemical or biosignature indicators that might point to habitability. The observations made by the telescope are also anticipated to provide fresh perspectives on the early development and formation of the universe. The JWST can recognize light coming from some of the earliest galaxies formed after the Big Bang, providing a more in-depth look at how these galaxies changed over time. This data will assist researchers in improving their models of cosmological evolution, including how galaxies merge and expand over billions of years, beyond the scope of its scientific goals. The JWST is a technological marvel, demonstrating human inventiveness and international cooperation. Numerous people were involved in the development of its technological innovations, including its deployable sunshield and segmented primary mirror, which needed to be precisely aligned after launch. These technologies represent the culmination of a century's worth of research and development, and have set new space telescope standards. Furthermore, The information gathered by the JWST will play a crucial role in advancing our comprehension of the fundamental processes of the universe, such as studying how light and ordinary matter interact in galaxy formation or comprehending the life cycle of stars, from their formation to their demise. This will ultimately provide a deeper comprehension of the forces that shape the universe. The objective of the telescope also incorporates public participation. Through the dissemination of stunning images and scientific findings, the JWST aids in encouraging the next generation of scientists and engineers. Education initiatives and outreach programs will make use of what the telescope has discovered to arouse curiosity about space science and technology among students and the public at large. As the JWST continues its mission, it will undoubtedly lead to numerous findings that challenge existing hypotheses and elicit new cosmic questions. Each new image and dataset will help gain a deeper comprehension of our universe, exposing its complexity as well as its wonders.